Hello, welcome to the first video in the series Chemistry that will cover the material for this upcoming school year. These videos were started because of hybrid learning during the time of COVID, but the goal is to get a complete set so that you'll have these as a reference as you go through the school year. This can be really helpful if you're going to be out for an extended absence, or if you were confused about a topic that we covered and you want to go back and you want to see the instruction provided again. So with this being the first video, it says packet number 1 is measurement. And the first topic that we're going to cover in chemistry is measurement. A lot of this chapter should be review. You have done things before like the metric system. And so when we go through the base units that we have here, you guys should already know those. You've converted by shifting the decimal to go from a kilometer to a millimeter. You've done things like scientific notation, and you've done things like, well, you may not have done significant figures, but I would say 60% of this chapter should be reviewed. We're going to go at a pretty good clip. If you're really struggling after this first chapter, you might want to, get together with me and have a chat. I've had students before that showed up for the first day of chemistry, and they didn't have a calculator, and they said, well, what do I need a calculator for? This is a science class. Chemistry is, I would say, the chemistry that we're going to do is going to be about 50% mathematical in nature. So it is a very mathematical based class. But why is measurement our first packet? Well, they always say in English, or like in life, if you didn't write it down, it didn't happen. Well, in chemistry, if we can't measure it, we really don't consider it. So we really only look at the things that can be measured. So what do we use to measure? Growing up in America, you use things like inches and feet, and that's kind of ridiculous because the entire rest of the world, except for 2 countries, uses the metric system. It's much easier to convert, it's much easier to use, and it operates off of base 10. So every time we change, all we have to do is move the decimal. You don't have to multiply to go from feet to inches. There's 12 inches in a foot. You don't have to do all of that. So everything that's done in science is done in mathematically in the metric system. And in terms of language, it's Latin. So we will run into some Latin terms in chemistry, not as much as we do in anatomy and biology. Well, the entire metric system is made up of base units. And there's only 7 base units. Now stop and think about how many things you can measure. You could probably think of 100 different measurements that you can make if you really started getting creative. And that's all built off of these 7 base units, which is kind of crazy. And I only have 4 of them listed here. Some of them, like the brightness of light, which is a lumen, we're not going to use. The charge of an electron or electric charge, we're not going to use those things. So the 4 that we're going to use a lot are length, mass, time, and temperature. You should know these already. See if you can pause the video if you need to, and you can come up with what the metric units are for length, mass, at least length, mass, and time. All right, how'd you do? Length is a meter. So the base metric unit for length is a meter. Time is seconds. And you probably said gram for mass. Actually, it's kilogram. This is the only base unit that we put a prefix with. But to make things simple, we're just going to say a gram. Temperature. How many different temperature scales can you think of? Probably think of Fahrenheit, Celsius. And then there's a third one called Kelvin. So Fahrenheit, we're just not going to use. If you've done labs in junior high or your freshman year and you had to take measurements, you probably took them in Celsius. So this is the one that's most commonly used. But Kelvin is the SI metric. So this is actually metric unit, but it's a really kind of abstract scale to give you an idea of how different it is. If you want to get degrees Kelvin, you have to take the Celsius value plus 273. So 0 degrees Celsius is 273 degrees Kelvin. At 0 degrees Kelvin, all molecular motion stops. And so that's kind of how they base that scale. We're really not going to use this all this much, but I did want to jot it down. Well, next to these base units, so everything that we measure is a combination of these. So for example, if derived units, then our combinations are 2 or more base units. So if I wanted to measure velocity, and you're going to think of velocity as speed, that's going to be the number, that's the distance that I travel in a given amount of time. So my unit for this is meters over seconds, or meters per second. You might be stopping at this point and thinking, wait a minute, I missed a pretty important base unit. If you go to the store and you buy a large bottle of pop, you call it a 2 liter. Or if you get a jug of milk, you call it a gallon. What about volume? Did I miss volume? No, it turns out the volume is actually a derived unit. So if you had a cube here, and you wanted the volume of that, you would do the length times the width times the height. Well, your length, width, and height would be in, let's say your length, width, and height are in centimeters. The volume of this cube is going to be in cubic centimeters. Or another thing that we can do is, what they did was they took cubic centimeter of water. So if you take a cubic centimeter of water, that is going to be equal to 1 milliliter, or ml. And so a lot of times people will say the base unit for volume is a liter. I don't want to make an equivalency there, but that's actually a derived unit. It's length, it's distance times a distance times a distance. And you do need to know that a cubic centimeter is equal to a milliliter of water. So these are equal. So what's density? Density is mass divided by volume. Well, we already said volume is a derived unit. So now we've got a double derived unit. We've got mass, which is going to be in grams. And we're going to do, a lot of times this is written as grams per cubic centimeter or as grams per milliliter because they're equivalent. And hopefully that gets you back in the know on your metric units. And I could either do one, the first video is either going to be 2 very short videos or 1 really long video. I think I'm just going to make 1 really long video and we'll do a decimal shift here. Now, you know what? I think we'll go ahead and we will take a break and we'll stop the first video here. So I'm just going to slide this back up. What you'll see is, I should have mentioned this at the beginning as well. So for this lesson, you had a packet that you were given, and this packet has very general headings. It's not like you might have done in other classes where you have a page and you fill in sentences. So the packets are only to help keep you organized. They give you section titles, but you'll do all your notes then based on what we talk about. And if you had been present in class, the lesson we did in class is very, very similar to this, and the notes will be very, very similar. So that, again, the packets are just to kind of help keep things organized. Or if I need a diagram, I'm not the best at drawing, so I'll have my diagrams preloaded. All right, so we're going to call that good. for our first video. And the next one we'll do how to convert in the metric system by using decimal shift. All right, thanks for watching.